So I want to talk about inputs and outputs and a couple words associated therewith. So if you have a function what's your favorite function?
F of x.
Cool.
Equals 0.
Don't understand.
The one that gives you 0. Okay, that's also so. Let me collect a couple examples to play with here. So Zach's example, maybe we call that z of x is 0. Okay, now this is a little bit confusing, right? Because when I say z of x equals 0,
It's always 0.
yeah, what I mean is that this thing is always 0. So to keep that straight from when is z of x equal to 0, which I write sometimes, you guys recognize that those are kind of two different ideas?
Yes.
So I'm going to write this, which is going to say this thing is actually the function 0.
Cool.
You guys see that? As differentiated from this is a function that is sometimes 0, and I would like you to find the x's when that's true. You guys see that?
Yeah.
Okay, so that's one of my examples. Anybody else got another function example they want to talk about? What else you got? So, recall from other places.
F of x equals 3x plus 2.
Okay. So here's a line, right? 3x plus 2. Let's see. We should have a function from trig class. Anybody got a favorite function from trig class? Anybody remember a trig function at all?
Sine of
Sine.
x. Sine of x.
Cosine, tangent, whatever you want.
Sine of x.
Cool. I'm going to start with sine, just because.
I remember
Okay, let's see. Probably I need a rational function. Anybody remember what a rational function is? Nah?
that. Yeah, rational. Right?
This thing?
Yeah.
That's a radical.
Oh, right. Cool. All right. A rational, an irrational or a rational?
Rational function.
Rational.
You guys remember what a rational function is?
I.
Okay, how about what's a
Fine.
rational number?
1, 2, 3, above 0, and it's
Fractions.
not repeating.
Any ratio?
No.
Any,
No.
any whole number integer. All real numbers. Except 0.
Okay, how about a rational number is a
Back.
fraction?
Oh. Okay. Because it's a ration of something.
Because it's a ratio of two
Yeah,
things,
yeah,
right? It's
yeah.
a ratio of two integers specifically.
Right.
Okay, so a rational function is going to be a function that is a ratio of,
Something else.
Over x.
yeah, like polynomials, right? Like it's a polynomial divided by a polynomial.
Whoa. Okay. So the question.
So like the easiest one I can think of is maybe like 1 over x.
Okay.
Okay?
Oh, is that the...
Yeah. That's a good example of that.
Oh, absolute value.
Okay, so I think you guys have a whole bunch of examples, right? So like, here's a massive examples of functions. What I want to highlight here is inputs and outputs and domains and ranges.
Okay.
Okay? So if I have some function, like any one of those, what's over here?
X.
Yeah, that's kind of X land, right?
So,
Okay, so that's where the X's live.
yeah.
As long as it's a function of x, right? Okay, so if I'm not sure that it's a function of x, like it's a function of t, or it's a function of theta, or it's a function of I don't know what the heck, what is this more generally?
The input.
Yeah, that's the input stuff. So things I want you to know about this block. That's where the x's, right, sometimes, or the t's or the thetas or whatever. That's where the inputs live. What is this blob called? Do you remember this word? Like, what is this set of all the inputs called?
Domain.
You guys with me on that?
Yeah.
So the domains on this side, that's the x's or the inputs. I really would prefer if we thought of inputs in this class,
Okay.
because you guys are getting to the level where it's okay for us to do functions of t or functions of theta, right?
Okay.
Like you guys have seen those before. All right, how about this side? What's the corresponding stuff on this side?
F of x.
Yeah, that's f of x's, right?
Which is the outputs.
Which is outputs.
Range.
And this is the range. You guys with me on that?
Yeah.
Okay, so I would like to consider those things for my examples, right? Okay, so I'm going to use some funny notation here. I'm going to say z colon, and what I mean by that is z takes. So what kind of things can I fit into this function z of x is 0?
Anything. All real numbers.
Anything in our land, we're going to say all real numbers. Okay? And what does z output?
0.
0. So
Z is a funny function, right? It takes whatever you give it
Makes nothing.
and just tosses it and gives you 0 back,
real
right?
numbers, comma 0.
So this goes from the real numbers to
0.
0.
Yeah.
Just the one thing by itself, right? Okay, so when I'm writing a list of things or just one thing by itself, how do I denote that? What's the math thing for this stuff is a list?
Brackets.
Which kind of brackets?
Closed.
No. Nice try.
Open.
No.
Square.
No.
No.
Oh.
That's close.
That's what I thought.
Brackets.
What kind of
So maybe
brackets
not
are we
brackets.
talking about here?
What's the other kind of bracket? It's not the square bracket or the parentheses, it's the
wiggly one.
wiggly one.
Oh.
I didn't know that was a bracket. I thought that was like a wiggly thing.
Yeah, so these are called sometimes braces,
Oh.
right? So this symbol means this is a list. You guys with me on that? So if I had a function that only output either 0 or 1,
Yeah.
0.
then I would have a list, right? 2 curly braces, and in that list would be 0, comma 1.
Gotcha. Okay.
You guys with me on that?
Uh,
What would a function like that have to do with? In other words, where would you see a function that was only 0 or 1?
Computer system.
Yeah, inside computers or, well, I mean, there's one on the back wall there.
Fire alarm.
Yeah, sure, that one's also one. I was thinking of the light switch specifically.
Oh,
But the
yeah.
fire alarm's definitely also a either on or off thing,
Yeah.
right?
Yeah.
Don't test that. I have no idea if that sets off the sprinklers. I kind of hope it does. You guys cool with this notation?
Yep.
So this says z takes the real numbers to the list of 0,
Yeah.
which I would say as z takes the real numbers to 0.
Yeah.
That's cool with that?
Yeah.
Which of these is the domain?
The domain
is the real numbers.
Is the real numbers, and the range is
0.
list.
just the list of
It's
0.
just the list. Yeah.
Cool.
In this case, it's 0.
Question marks? Cool. All right. Where's your line take? What's your line's domain?
Real numbers.
All real numbers.
numbers.
All real numbers?
So all real numbers.
Cool. Okay.
But you don't. It's not a list. It's just a.
Yeah, it's not a list, it's just all of R. Cool with that? Okay. How about sine of x?
Ooh, this is interesting.
This one's more interesting. Yeah, we might need a picture. You guys remember what sine of x looks like as a picture?
Yeah. So
Yeah.
you do.
Okay.
That's the midline.
It's the what now, Zach? No, that was good. It's the no, it's not the one that's a whoop-de-doo. That's x cubed.
Aren't they all
No,
whoop-de-doo?
it's a whoop-de-doo.
Aren't they all
Like,
whoop-de-doos a
horizontal
little bit?
whoop-de-doo.
Yes, they are all whoop-de-doos a little bit. So this one is
Stretched- they're stretched out
specifically,
whoop-de-doo.
it's the hand gesture that I'm liking, which is something like this or something like this, depending on how you.
That's what I was doing.
I know. Where does it start?
At midline at the origin?
It
Starts at 0, goes
0 pi.
Does it go up or down?
It goes up. Okay, from the midline.
yeah.
From 0 down.
Goes like this.
Exactly.
Goes
Yeah?
0,
Yes.
0 pi.
Okay.
Pi would be 2.
How do you remember that? You guys all just have this memorized?
Wait.
Because we know
Yeah. Unit circle land,
Yeah, exactly.
right? So to recall this, you might think, okay, unit circle.
So anything from 0 through 6.
Which side is the sine side of the unit circle?
Right. Top left. Top left and top right. So from,
Oh, not that thing.
from 0 to
Which side of this little triangle is the sine side? Has it been a while for trig class?
Yeah. I don't understand.
Okay, that's all good. That's why we're doing this, right? We're reviewing things that we may have forgotten. So, what's the thing you use all the time in
Oh, it's
trig
the
class?
Y side. It's the up.
Yeah, how'd you figure that out?
Because I remember that slope was sine over cosine, or x over y, or x over y. Something like
Okay.
that. Yeah, and
You threw a bunch of stuff together. Easier than that. What's the acronym that's, yeah, SOHCAHTOA, right? So it's the, which side? It's the opposite side, right? Because the hypotenuse is 1, right?
Yeah.
You guys remember that? Okay, so sine's the opposite side, which starts out, when I'm at 0, how tall is the opposite side?
0.
Yeah, it's 0 tall.
0.
Hence you start here.
Makes sense.
And then as you increase theta, right?
Yeah.
What happens to the opposite side?
It gets larger.
It's larger.
It goes up until
It
you
gets
hit
smaller again.
1, and then it goes down again, right? So it goes up till you hit 1 high, and then it goes down again.
Yeah.
So this is 1 here. What's the angle that goes with 1?
2 over pi. Pi over 2.
90
Pi over
degrees.
2.
Or just
Or-
90 degrees.
90 degrees.
90 degrees.
If you're in the
And then it goes down to -1 also.
And then, yeah, this goes down to -1, and where does that happen?
Negative pi over 2.
Negative pi over 2, or,
-90 degrees. Or
yeah,
90.
or
Or
out
90.
here again, right? It happens at
It also hits
3 pi over
it also hits the
2,
x-axis.
and then another
Pi.
180 degrees later or something, right?
Yeah.
Sorry, 360 degrees later.
Right. Cool. So,
Cool? Questions?
domain.
So, what I want to know is the domain. So,
-1.
what are the inputs for angles that make sense for sine?
0 through 60.
0 to 90.
0 to 90.
You can think about it as 0 to 360. That would be okay. Can I go around this circle a couple of times and still have that opposite side make sense? Yeah. Can I go around the circle backwards and have the opposite side make sense?
Yeah, it's all good.
It is, in fact, all real numbers.
Oh, that makes sense.
Any real number can be thought of, right, as an angle that would make sense here. Because you might have to go around a bunch of times before you stop, right? But then once you've stopped, it's just the distance off the x-axis, right? Either up or down, depending. You guys good with that?
Yeah.
I realize it's been a while for trig class. I'm not going to expect you to know tons and tons of trig right now, okay? I'm just trying to, like, put some grease on rusty gears in your heads. What's the output?
-1 on 1. -1 to 1.
Yeah, it's like all this stuff from -1 to 1, right? So, do you guys remember the trick about if you've got a graph, to get the domain, you can smash onto the
The x-axis.
x-axis.
And then if you want to get...
Right, so if you take this picture, right, you got your ink from your graph. If you just smush that thing onto the x-axis, there's graph ink everywhere. That's that all real numbers for the domain. But if you do the same thing for the range, what do you do?
Smash the...
Yeah, you got to smush this way, right?
And it's only one.
And there's only graph ink from
Not the negative.
-1 to 1, right? The highest and the lowest that function ever gets. So, now I need a way to write stuff between -1 and 1.
So, x in the middle and then
Oh.
Yeah, you could write it as an inequality, but that wouldn't
No.
fit here notationally.
You use this.
Close brackets.
Yeah, so now you need brackets. So I think you want to go from -1 to 1, right?
Yeah.
And then, is -1 included or not?
Yes.
They're included
Why?
because
have
you can have.
Yeah,
negative
because
one
you can
and-
have that as an output, right? So that's a square bracket on -1. And +1, is that included or not?
Yes.
Same thing.
Included. You guys good with that?
Yeah.
Okay. All right, say, how about for r of x is 1 over x?
All
Um,
not.
Think so?
no, you can't.
Oh,
Except zero.
except for 0, right?
So not all real numbers. Whole
So
numbers.
not all real numbers.
All whole numbers.
No.
So 0,
Zero is a whole
infinity,
number.
so 0 to
Integers, all
infinity,
integers.
and
No,
0
zero
to
is a
negative
net integer.
infinity? Is it like 0 to infinity and 0 to negative infinity?
Okay, yeah, we could write it as 2 intervals, right? We could write -infinity up to 0,
Yeah.
But don't.
and
include
then
zero.
put a not included,
Yeah.
and then add that. So if I was going to write that, I'd write -infinity up to 0, not including 0. Why didn't I include -infinity?
Because you can't.
Because you can't, it's
can't-
not a number.
It's not a number.
Yeah,
It's
'cause
an
it's not a
idea.
number, don't
It's
be
an
crazy.
idea.
Quantifiable.
And then I'd need to also go from where?
0 to positive infinity.
0 to positive infinity. And how do you stick intervals together?
You.
Yeah, there's a adding symbol for intervals, which is this thing.
Couldn't you also just do all the numbers and then x can't equal zero?
Oh, so close. You almost had it. That's the right idea.
Is not equal to zero?
So another way you could write this is you could also write r takes all the numbers, and then you want to take 0 out, right?
So x
So write like a grade schooler. All the real numbers,
except
take away.
0.
Yeah. And then what do you want to take away?
0.
0. That seems weird, right? Because if you take
absolute
take
values.
0 away, that doesn't do anything, right?
Yeah.
So what do you want to do? You want to take away. How do we write 0
Quantities.
as a point?
0 commas.
0, 0.
With a list, right?
Oh, yeah.
So you want to do r take away the list.
Oh.
0.
Oh, that goes into set. That reminds me of set theory.
That is set theory.
Oh, okay.
Yeah, so I would call this thing, this is interval notation, and this is set theoretic notation. I don't care which one you use particularly. I would personally lean towards this just because easier. Right? It's usually easier to list the problem points and just take them away than it is to break it all up into intervals and add the intervals together. But whatever, your choice. Now we have a problem. I need to know what the range is for 1 over x.
Oh, the range is
So I think I probably need a picture. Where do you get a picture for 1 over x?
Just draw it.
It looks like it has the same range as sine does. I feel like it goes up to 1. I feel like after you go to
No, because you could have 1/2.
because it's a fraction, so it can't ever be.
Okay, so what do I know?
Unless you put 0.5 underneath it.
I know that it can't be 0, right?
So it's all.
You guys see that? So I know my domain is everything except 0, so maybe I should think, okay, there's some kind of vertical asymptote nonsense going on at the y, right? Okay, now, how do you plot a new function?
You just plug it in and see what your output gets. So if you plug in 1, you get 1.
Okay, so if I go over 1, right,
You go up 1.
I should go up 1.
You go over 2, you go up a half.
If I go over 2, I'll go up a half.
You go over 3, you go up a third.
If I go over 3, I'll go up
Oh,
a
that's
third.
So it's slowly approaching, like,
So the x-axis is an
Horizontal.
asymptote as well.
Yeah, the x-axis is a
Asymptote.
asymptote, but it's not a vertical asymptote, it's a
Horizontal asymptote.
horizontal asymptote. So I'm thinking, okay, so it tails off that way.
But then, because if you plug in like a half,
Okay, so if you do 1 divided by a half,
you get 2.
you get 2.
So then it slowly approaches the y-axis too. It's the same.
Uh-huh. It tails in on the y-axis too,
It never touches though.
and never touches.
So our question is, what is our range? And so it's.
Wait. You forgot the other
same
side.
thing on the other side.
So on the other side, when you have -1, what's your output?
-1.
1 over -1 is -1, right?
So yeah, same thing on the opposite side.
Well,
No?
not the same thing, right?
Oh, a reflection.
Yeah, it's a reflection.
What about
right?
the inverse? Does it have an inverse?
Well,
It does have an inverse. We're not there yet in the class, but you all might remember that there's a way to get the picture for an inverse, right?
Yeah, just
Which is you take the line y equals x and rotate the whole thing,
uh-huh.
and you get the same picture. If you do 1 over 1 over x, what do you get?
1 over 1 over x. You get 1 over x.
No.
We did that, no?
If you do 1 over 1 over x,
You get x over, you get x.
you get x, right?
Yeah.
So if you do this thing twice, you get back to where you started.
Yeah.
That says it's its own inverse. It's weird.
That's cool.
oh, that's right.
Cool? Questions?
So we're finding the range.
So we need to find the range. So where do I find the range from?
What?
Yeah, I have to smash everything onto the y-axis, right?
Uh-huh.
So,
All real numbers
close.
Except 0.
Except 0, because it tails in on 0, right?
Right.
Exactly.
So this takes all real numbers except 0 to
All real numbers except
all real numbers except 0. Which you can write, again, in either of the two ways. Oops.
Union.
What symbol was it supposed to have here?
Union.
Yeah, that's adding two intervals together, right? So that should be the union.
Yeah.
Cool.
Yeah.
All right, now I got to do absolute value of x. Last one.
The domain is all real,
Okay, the domain's all real numbers.
and the range can't be negative, so.
And the range is,
So-
yeah, you can't get a negative number out, right?
0 plus infinity.
So from 0 to plus infinity. I'm done with that. What kind of brackets do you need?
Encompass 0, but don't encompass infinity.
Yeah, close and 0, open and
Include 0, not including infinity. What does the picture for absolute value look like?
the V.
Yeah, that's a V shape, right?
Uh-huh.
Okay. So if you smash this way, you get all real numbers. That jives. If you smash this way, you get
All real numbers except negative numbers.
the reals except the negative ones, right?
Mhm.
So this thing here, you could write as r plus.
Oh, okay.
Oh, that makes sense.
That's the positive reals.
Mhm.
I would have a tendency, if I was you, to stay away from using that notation for really precise things,
Mhm.
because it's not totally clear whether that should include 0 or not.
That's fair.
You guys see that?
Yeah.
Like, this way it's totally clear that I mean to include 0.
Mhm.
That one, no.
Mhm.
Cool. Questions, Steels?